Hi guys, welcome back to my YouTube channel. This is Tanushree. So in my last video I did the topic in a physics. So in this video I'm going to do the topic in the mathematics. I chosen from the mathematics. So the topic name is Laplace transform. So before going to that, please do subscribe to my YouTube channel and click on the bell button icon that will notify you of my upcoming videos. So let's start the video. Okay. Laplace transform. We go through the definition first. Let f of t be any function with a real variable t. Then the Laplace transform of f of t is denoted as L of f of t. Okay. The Laplace transform, it is denoted as L of f of t, and it is defined as L of f of t is equal to integration over 0 to infinity e power minus st f of t into dt is equal to f of s. The whole term, which is also written as f of s. Okay, then L of f of t is equal to f of s. This is what the definition of the Laplace transform. Okay, next we move on to the sum of the elementary functions of the Laplace transform. Okay, sum of the elementary functions of the Laplace transform. In that we have the too many important functions that we'll use it for the problems. So for that we have to solve that functions. So first function is L of e power kt is equal to 1 divided by s minus k. So we have to solve this and we have to prove this function. So firstly we have to take the definition. Okay. By the definition of LT means linear transform, L of f of t is equal to 0 to infinity e power minus st f of t into dt. This is what the definition of the Laplace transform. So here the f of t which is replaced by e power kt. Here f of t is equal to what? E power kt. Therefore L of e power kt, which is equal to 0 to integration over 0 to infinity e power minus st f of t is nothing but the e power kt into dt. So the integration over 0 to infinity, here the exponential, the base is same, so we have to add the powers. Okay, so e power minus st plus kt into dt, that is the rule. Okay, next integration over 0 to infinity, here we take the t common. Okay, minus t, we take the minus t common, then we get s minus k into dt. Okay, then 0 to infinity, here we have to integration with respect to t. We have to integrate with respect to t, then we have to take e power t. The integration of e power t is e power minus t is e power minus t, and with the coefficient s minus k. So we have to put the coefficient in the denominator. While we are doing in differentiation, we have to put the coefficient in the coefficient of the exponential form. Okay, when we are integrating the function, so we have to put the coefficient in the denominator. Okay, so here the coefficient is s minus k, then integration 0 to infinity. After this integration we have to put the limits and solve. Okay, I will take the common s minus k from this, and the remaining part is e power minus t of s minus k. Okay, then 0 to infinity, which is equal to 1 divided by s minus k. Okay, here we have to put in the place of t with the starting upper limit and then minus lower limit. E power minus t means minus infinity into anything, that will be infinity only, then minus e power minus of 0 into anything will be 0. Okay, it is equal to 1 by s minus k. Here e power minus infinity means 0, e power 0 means 1. Okay, here we carry the minus, right? Here we carry minus. Here the coefficient minus is there, so we have to carry on with this. So we got like this, minus of s minus k is the coefficient of t, so we have to take in the denominator while we are integrating. Okay, this minus become plus, then which is equal to 1 divided by s minus k. So we got the proof for L of e power kt. This is this elementary function that will used for problems. I will show you while I am doing the problems. So this is what the first function we did. Yeah, this is the second elementary function that will used for Laplace transform. So we have to prove that L of sine of kt is equal to k divided by s square plus k square. So by the definition, as we know, by the definition of LT, L of f of t is equal to integration over 0 to infinity e power minus st f of t into dt. Okay, here f of t is equal to sine kt. Okay, f of t is equal to sine kt. Then L of sine kt is equal to integration over 0 to infinity e power minus st as kept common, and f of t, it is nothing but sine kt into dt. Okay, here we can apply the formula that integration e power 0 to infinity e power ax into sine bx into dx. In this formula we are going to apply that e power ax divided by a square plus b square, then a into sine bx minus b into cos bx. This is what the formula. So according to this formula we have to substitute the above required equation, required solution. Okay, here e power ax means e power minus st. In the place of a we are going to put a is equal to what, minus s, and b is equal to k, x is equal to t. Okay, which implies here the required solution we have to convert into this formula. E power a means minus s, x means what, t whole divided by a square means what, e power a, right, e power minus s whole square, then plus k square into of, okay, here a means minus s, then minus s, then sine b means what, k, x means what, t, minus b means what, k, into cos b means k x. So this is what the substitution. Okay, after this we have to apply the limits, lower and upper limits we have to apply. Here we are taking the denominator as a common term from this term. Okay, minus s whole square means s square plus k square, remaining term I will write e power minus st of, okay, minus s of into sine kt minus k into cos kt with the integration 0 to infinity. So I will apply the integration, limits to this solution. Okay, yeah, 1 divided by s square plus k square. Here we apply the infinity to infinity which replace the t. Okay, we apply the first, we have to apply the upper limit, then minus we have to apply the lower limit. So first we apply the upper limit. Okay, here infinity into anything will be infinity. Okay, then minus s, okay, sine infinity, okay, minus k cos infinity, minus of e power, next we have to apply the lower limit, that is nothing but 0, okay, then minus s sine 0 minus k cos 0. Okay, here 1 divided by s square plus k square. Here e power infinity is nothing but 0. 0 into anything which is equal to 0. Okay, then 0 minus, here e power 0 means what? 1. Then minus, yes, sin 0 means what? So sin 0 is a 0. Okay, this term becomes 0. Here minus into minus, what happens? Plus. Then here the 1. Okay, 1, e power 0 nothing but 1, and minus into minus plus. Then k remaining, cos 0 means 1. 1 into k means k. Okay, this is what the thing. So we will write it as here, sorry, e power 0, it is nothing but 1. 1 into k, not plus or minus. 1 into k, and the minus into minus becomes plus. So I will put it here, plus. Okay, then 1 into k is k. So therefore k divided by s square plus k square. This is what the second function that we proved. Next, move on to the another function. So here the third function is L of cos kt is equal to s divided by s square plus k square. So this function is also similar to that of a sin kt that we have done here. Okay, this is the same function, we have that. We have to prove that. But here we have the different formula. Okay, we will do this. Here, by the definition of LT, L of f of t is equal to integration over 0 to infinity e power minus st f of t into dt. Okay, here f of t, it is substituted by cos kt. Okay, f of t is equal to what? Cos kt. Then L of cos kt is equal to integration over 0 to infinity e power minus st. Here f of t, it is nothing but the cos kt into dt. So here we are going to apply the formula in the same way we had applied for the sin kt. So we apply here integration over 0 to infinity e power ax into cos bx into dx. We have to apply this formula to this obtained solution. It's slightly different from, actually it's similar to that formula that we used in a sin kt, and its only difference is that e power, in that side we taken the e power ax into sin bx. Here we are taking e power ax into cos bx because we have to prove the cos kt. Therefore here e power ax, same as in sin, and divided by a square plus b square into of a into cos bx plus b into sin bx. This formula, it is used to solve this function. Okay, here same way a is equal to, we have to put a is equal to what? Minus s, and b is equal to k, then x is equal to t. Therefore the obtained solution, we have to substitute this obtained solution to this formula. Okay, e power a means minus st divided by minus s whole square, minus s whole square plus k square into of s. A means minus s, cos bx means cos, k x means t, plus b means k into sin bx means kt. This is what the substituted formula with the limits 0 to infinity. Now we have to apply the limits. So we have taken this common from this side. Here minus s whole square is s square plus k square. Okay, then e power minus st minus s into cos kt plus k into sin kt with the limit 0 to infinity. So we have to apply the upper and lower limits. First we have to apply the upper limit, then we get square plus k square. Okay, e power minus infinity. Okay, when we apply e power minus infinity, which is equal to 0, then 0 into this whole term becomes 0. Okay, 0 minus of. Okay, next we have to apply lower limit. Okay, e power minus 0, of minus s into cos 0 plus k into sin 0. Sin 0 becomes 0. Here cos 0 means 1. Okay. Here e power 0 means 1. 1 into 1 is 1. Then minus into minus is plus. Then we get 0 plus s. Okay. I will write the coefficient. Okay. Then we get s is equal to s square plus k square. This is the proof, that is L of cos kt is equal to s divided by s square plus k square. This is the proof of the third elementary function that I had in this video. Okay. Next we move on to the another elementary function. So this is the fourth one, elementary function, and we have to prove that sine hyperbolic kt. So we have proved the sine kt. So now we have to prove the sine hyperbolic kt for the linear transformation. Then it will be proved that k divided by s square minus k square. Let we prove this. Okay. By the definition of linear transform, L of f of t is equal to what? Integration over 0 to infinity e power minus st f of t into dt. Here f of t, it is nothing but the sine hyperbolic. Here the formula for a sine hyperbolic kt is, as we know, e power kt minus e power minus kt divided by 2. Okay. Then similarly for a cos hyperbolic kt is e power kt plus e power minus kt divided by 2. And for a tan hyperbolic, okay, tan is nothing but what? Sine by cos, no? So therefore we had the 2. Then 2 get cancelled, sine by cos. That is e power kt minus e power minus kt divided by e power kt plus e power minus kt. This is the formula for the sine hyperbolic, tan, cos hyperbolic and tan hyperbolic formulas. Okay. We are going to apply this formula and we get the linear transform elementary functions. Okay, we have to, now here it is a different step we are telling. So for a sine hyperbolic, we get that L of sine hyperbolic kt, which is equal to L of sine hyperbolic kt. What we have formula? This one. Okay, this one formula we have to write. So I will take the 1 by 2 as a common, 1 by 2, and then L of Laplace that I will apply for the first term, that is e power kt. L of e power kt minus then L of e power minus kt. Okay, now we have to apply the Laplace for the sine hyperbolic formula. We have to obtain the linear transform. Okay, L of e power kt that we have solved in a previous function, that is 1 divided by s minus k, then minus e power minus kt means the same thing we have to write s minus k. Here there is a plus, therefore s minus k. If there is a minus, minus into minus what? It will be plus here, because here e power minus kt, so minus into minus what happen? Plus. Here plus kt, so we are writing s minus k, that we have proved. Next we have to take the LCM for this. So a minus p into a plus p, that is s minus k into s plus k. Okay, the coefficient, we have to cross multiply this, s plus k minus of s minus k. Okay, which is equal to 1 by 2 s plus k minus s minus into minus plus k. Here a minus b into a plus b, it is nothing but what? A square minus b square. Okay, that is s square minus k square. Here yes get cancelled, Then k plus k means 2k, right? 2k divided by s square minus k square. Here 2 get cancelled. We obtain the function k is equal to s square minus k square. This is the elementary proof for the elementary functions. Next, having the last function. Okay, this is the last function we're going to prove. Okay, we know that cos hyperbolic kt formula, that is e power kt plus e power minus kt divided by 2. So we are going to apply the Laplace on both sides. Then L of cos hyperbolic kt, which is equal to 1 by 2, I will take the common. Then L of e power kt, I will apply the Laplace transform to the both terms, plus L of e power minus kt. Okay, then 1 by 2 into of, here we know that L of e power kt is what, 1 divided by s minus k, plus here e power minus kt is there, so 1 divided by s plus k, as I told you in the previous function. Okay, here we are going to take the LCM and cross multiply. S plus k, okay, plus s minus k, then a minus b into a plus b, what, a square minus b square, right? Square minus k square. Here minus k plus k get cancelled. S into s, what, 2s. Okay, s square minus k square. Here 2 get cancelled. We obtain s divided by s square minus k square. This is the proof for a cos hyperbolic kt. So these are the important proofs that I explained you in this video, which is very important for upcoming problems. So I will solve in my next video. So please do watch that video. Thank you for watching this video, and please do subscribe to my YouTube channel and click on the bell button that will notify you for my upcoming videos. So please do the like, share and subscribe. So thank you for watching. Thank you.